Hello everyone, and thank you for joining me today. Please visit the library's YouTube page to see our previous moon viewing video. So hello, I'm Ms. Emily, and we are going to get ready for International Observe the Moon Night for Saturday, September 26th. Now, let's become a selenologist. That is a person who studies the moon. So you can view the moon visually, and for that you might use your own eyes or telescopes or orbiters. The Lunar Reconnaissance Orbiter recently updated all the moon maps, and it shows really good detail of the impacts and the ancient volcanic activity and the moon's topography. Look at this image here. Can you see the highest and low points on the moon? Notice the colors they chose. Why do you think they used those colors? Now, you can also view lunar eclipses. Our next lunar eclipse will be November 30th, so make sure you watch out for that as well. It'll be almost complete, not quite. You can also look at the moon with just your eyes for enjoyment. Maybe you want to draw the moon, or write about the moon, photograph it, or maybe even just dance under it. Whatever you like, the moon is there for you. Other selenologists study the moon physically. They can study samples from the actual lunar landings or from various probes. They can look at the geology, like the rocks and the dust all over the surface. They can look at the atmosphere up above the surface. They can get seismic activity to see if there's any type of seismic activity still on the moon. They can even study biotic, if there's any living or formerly living evidence on the moon, as well as the gravity, since it is different than our planet. Just last year, India sent up an orbiter and a probe and a rover, but unfortunately they lost contact with it and it crashed. So in 2020, the NASA calendar here, they actually have some cool space projects listed in here. And if we go to this page right here, it actually shows you the names of some of the different explorations they're planning to have on the moon right here. So the ones that are already gone are the LRO and the Thymus Artemis. Things that are still to come are Viper, the Peregrine Mission 1, and Nova C. So they are still planning more things for around the moon. So let's look at all this stuff for around the Earth and even Mars, where Curiosity and Insight are currently on the planet. They're hoping to have Mars 2020 and ExoMars 2020 as well working in the future. If you're interested in one of these calendars, you can pick one up in the library's foyer. Now, on to the Lunar Touchdown Challenge. If you notice, I have a whole bunch of stuff here on my desktop. So, if you think about it, the most recent probe that was supposed to go and land on the moon, they lost contact with it, it crashed. They don't know if anything on there survived or not. They're going to have to wait until some other instrument gets over there, and unfortunately, they're landing different probes all over the moon, so it's not like they're landing all in the same place and go check on it. But you do want it to land safely, ideally. And so from the NASA and Design Squad, they have a challenge here. And this challenge is to make a rover or a lander to actually successfully land without losing your payload. If you are interested in getting the actual write-up, you can go to this link up here to get the PDF, and you'll be able to get this sheet. There's actually a couple of sheets to it with information. And so, if you look at this image that I'm showing you right now, it has various rover and lander images. Notice the legs, notice the shape of the body. There's a lot of similarities to these things. But for the most part, their legs have some type of spring or hydraulics in there to help cushion the landing once they actually come down. Now, the list of materials that are suggested on this form include one piece of cardboard. So this is a piece of cardboard I cut off from a box. There is a small paper cup or plastic cup. I did not have a paper cup or a plastic cup. I had this little styrofoam cup, so that's what I'm using instead. Again, do what you can. It says 3 index cards. I actually did have index cards. It has some regular marshmallows. I have 2 regular sized marshmallows here. It says 10 miniature marshmallows. Well, unfortunately, I don't have any miniature marshmallows, so what I did is I took the regular sized marshmallows and I cut them into 4s and I made mini marshmallows. I made 10 of them. It said for 3 rubber bands, so I have 3 rubber bands here. It said 8 plastic straws. I also do not have any plastic straws. I'm not sure if any of you watched my geodesic dome video, but I had to make paper tubes for that. So I just made paper straws from sail papers, and I took my handy dandy pen that is on my string here, and then I just put my pen on there. I started to roll the paper around it. Roll the paper nice and snug on there. Then with a piece of tape, taped down, pulled my pen out, and now I have a straw. And so I made paper straws, and it says I need a pair of scissors, which I have here, and some tape, which I got some masking tape. So basically, they first want you to design and think of the shock absorbing system. So again, we had those images earlier on the video. What can you actually build? You can draw it out ahead of time, looking at the materials, see what can you do to have that shock absorber. Next, you want to put that spacecraft together and attach the shock absorbers to the cardboard platform. So any of the thing that you're going to do the shock absorbers are going to be on the bottom here. Finally, you're going to add the cabin and the astronauts. So when we're done, this cup is going to be taped to the top here, and our 2 astronauts, or our payload, are going to go inside the cup. You cannot put anything on top of the cup, because the goal is so when you drop this, the marshmallows, the payload, don't fly out. Now if you notice, when I did this at a very small distance, everything stayed in. But if I do it from a higher distance, the marshmallows can actually pop out. So you want to be able to create something that's going to be a shock absorber and see how high you can get your rover, your lander, to fall and keep your payload inside the container. As always, if you create one of these challenge structures and it works or doesn't work, we'd love to see pictures or video. Make sure you send it to youthservices@olpl.org. And I would also personally like to invite you to our live program on International Observe the Moon Night, Saturday, September 26th. Make sure you go to olpl.org and click on the calendar. From there, you want to click on the program to be able to get the Zoom login code. We will be live on Zoom, so you need to make sure you go to the website, the LibCal calendar, and click on the actual program description so that you can get the login information for Zoom. Now, we will be observing the moon with our eyes, but if you have any special equipment like binoculars or telescopes, you are welcome to use them, but it's not required for our live International Observe the Moon Night program. Also, we will be looking south. So, since right now the moon is just a very small crescent, you might want to practice looking for the moon prior to the program so you know where approximately to look. Then you'll be able to have no problem on Saturday the 26th. Feel free to take a peek just after sunset and look for that moon. Looking forward to seeing you on the 26th. Bye-bye.